In this video, we'll talk about one of the most important ideas in programming, but also one of the simplest, and it's the idea of the loop. There are two kinds of loops that are supported by processing. One is called the while loop, and that's what we'll talk about in this video. There's another one called the for loop, and it's really the very same thing, but we just write it down in a slightly different way. And we'll talk about that in another video. But if you understand one of them, you have total understanding of the other. So what is this loop thing all about? It's really something you're very, very familiar with. And the idea is that when you're doing something, you keep doing it as long as some condition is true. And then when that condition stops being true, you stop doing it. So for example, suppose you're reading a book. If you're really enjoying the book, as long as there's another page to be read, you will read it, and then you'll turn the page and read that one. So as long as there are pages remaining, you will read them. When you finally reach the last page of the book, there are no more pages to be read, and so you stop. It's perfectly natural. That's the idea of a loop or of a while loop. As long as something is true, you keep doing it. For another example, suppose you're preparing a salad and you need to peel the carrots. As long as there are unpeeled carrots sitting on your chopping board, you will peel them. And so we might say that in while loop form as saying, while there are carrots left to be peeled, peel them. That's really all there is to a loop. So let's see how we would use this in processing. We write it this way. The word while, all in lowercase, and then a test, which we put between parentheses. This test is just like the if test that we saw in if statements. It's something that evaluates to true or false. As long as the test is true, the statement, here written in green, is executed. And then we test again. If test is true, the statement is executed. Then we test again. As long as test is true, statement will get executed over and over and over again. As soon as test is false, we're done with the while and we move on to the next statement in the program. So this works great if the statement is, for example, take one step forward. But suppose we want to do three things, like in our carrot example, we want to pick up carrot, peel carrot, put carrot down. Well, we can write this with curly braces, just like we did with an if statement. And so in this case, we have the very same construction, the word while, the test in parentheses, a bunch of statements that get executed every time the test is true. But by putting them in curly braces, all three statements get executed. So here we might say, while carrots remain to be peeled, pick up carrot, peel carrot, put carrot down. Then we test to see if there are carrots remaining to be peeled again, and repeat. That's the idea. Let's write some code and see this in action. Here's a drawing I would like to be able to make. It's just a long, thin graphics window with 6 circles inside it. Now, if this was really the picture I wanted to draw, I would probably just type 6 lines and draw each of the 6 circles. But suppose I wanted 1,000 circles or 10,000 circles, or I didn't know how many I wanted and I wanted to be able to experiment very quickly and have 6, then 5, and then 9. A loop is the answer because I can just change the number of circles I'm drawing very easily, and the loop will just run a different number of times and create that many circles. So let's write a little loop that will generate these 6 circles spaced out horizontally in my window. We'll begin with the basic while statement itself. The word while, an open parenthesis, a test, and then a closed parenthesis, and then we'll have an open brace and a curly brace for all of our lines. The test I'm putting here in red italics, will fill it in with something real in a moment, but it's going to tell us whether we need to draw more circles or not. As long as whatever ends up becoming need more circles is true, we will draw another circle. And then when that stops being true, we're done. So what are we going to do inside the loop? Well, certainly we'll draw a circle. Then we'll move the center to the right so that the next circle will be to the right of the old one. And we'll do one more thing, but I'll get back to that in a moment. Now let's think about what we need to set up before we run the loop. Well, first we need to know how many circles we want to draw. So I'll have an integer for that. And then we'll create a loop variable. we're going to have something that controls the loop. And in this case, it's going to be a variable that counts how many circles we have drawn. So up here, I will create that variable and I'll set it to 0, indicating that we haven't drawn any circles yet. Finally, I know that I'm going to be moving the circle each time I draw it. I have to start it somewhere, so I'll pick an X position for the start of the first circle. The thing I'm missing inside the while loop is something that lets me know how many circles we've drawn. I've already created a variable for that. I called it the loop variable. That's going to tell us how many circles we've drawn. And so in the loop, I will update that. I'll add 1 to it. So we always know we've just drawn one more circle. Let's take this abstract description and turn it into real code, one line at a time. I'll start with the first line, set up the number of circles. How many circles do I want? Well, I know I want 6 because that was in my drawing. So I'll create a variable, an integer, I'll call it numCircles, and I'll set it to be 6. So now I know how many circles to draw. Now I want to set up the loop variable, something that's going to count how many circles I have drawn. Well, okay, I'll call that drawn circles. And it's an integer, and it will have the value 0. So now before we've started the loop, we have not yet drawn any circles. So drawn circles is 0. All right, so that's it for the loop variable. Let's jump to the bottom, update loop variable, because I just took care of the loop variable, so let's do all of that at once. We know when we're in the loop that we've just drawn a circle, because that's what the other lines inside the loop are doing. That tells us that the number of circles we have drawn has just gone up by 1. So I'm going to change the variable drawn circles and add 1 to it. And you may remember the plus plus notation says add 1 to the value of drawn circles. So this is great. We have a lot of the work set up. We really have only one more essential bit, and that's to take care of this test. Now, how do we know if we need more circles? All we have to do is compare the number of circles we've drawn with the number of circles we want. And if we have drawn fewer than we want, then we need to draw more. Well, we'll just write that line. In between the parentheses, I'll simply write drawn circles less than numCircles. So this is true as long as the number of circles we've drawn is less than the number of circles we want. Every time we go through the loop, drawn circles becomes 1 larger. Finally, drawn circles becomes as big as it needs to be, and this test will be false, and we'll stop drawing circles. So let's go ahead and draw the circles and take care of the rest of the little stuff. To actually draw a circle, we know how to do that. We just call ellipse. And I've invented this new variable called circle x. That's going to be the x location of my circle. So after I draw every circle, I know I want the next one to be to the right. So I'll add, I don't know, say 100 units to the value of circle x. And because I've got this variable circle x, I have to initialize it somewhere, and that I'll do up top. I'll create circle x as a float, and I'll give it a starting value of, say, 100. This now is our entire nugget of this program that's involved in drawing the circles. In practice, this would be part of draw, and so might be other stuff above it and below it, but this is everything we need to draw our circles. To really lock this all down, let's pretend that we are processing, and let's execute this code and watch what happens. We'll dig into that in part 2.